In this video, we're going to be looking at Chapter 2 of the iGCSE Further Maths course, Quadratic Functions. This video will contain everything you need to know about Chapter 2. A quadratic function is basically a function that contains a variable to the power of 2. So, for example, x squared. Here's some definitions you need to know. A function is a set of ordered pairs, and in which every x value has a unique y value. For example, fx equals x squared plus 3. This basically means that a function is something that takes in an input and gives out an output. The input is the x value and is also called the domain, and the output, which is the y value, is the range. So if x equals 1, for example, then it will go into the function and come out as 4, because 1 plus 3 is 4. You will also need to know how to find the maximum and minimum point of the graph. In this sketch, this point is the minimum point, because it's the least part, and it is also known as the vertex of a graph or also the turning point of a graph. It's also basically when the gradient is equal to 0. So to find this point, you need to differentiate the function of the graph to find the gradient, which you should know from GCSE maths, and then make it to equal to 0 to solve for x, and then sub it back into the original equation to find the value of y, to find the coordinates of the point. Here's an example. If a function is equal to x squared plus 2x minus 3, here's a little sketch of the graph. And we are finding the minimum point. So the first thing you do is differentiate the function. In this case, all you have to do is differentiate it normally, so you bring down the power and minus 1 from the power, so it becomes 2x plus 2, and the minus 3 is gone. Second step, you make it equal to 0, so 2x plus 2 equals 0, because you're finding the gradient and you know the gradient equals 0 at the turning point, and then you find that x equals minus 1. Finally, you sub it back into the original equation to find the y value. So y would equal minus 1 squared plus 2 brackets minus 1 minus 3. And in this case, y equals minus 4. So the coordinates of the minimum point is minus 1, minus 4. The next thing you have to know how to do is sketching graphs. So if we use the function from earlier, it's pretty simple as long as you know your roots. So to do this, all you have to do is factorize. And in this case, the roots are minus 3 and 1. And from before, we know the minimum point is minus 1, minus 4. So it should be a cross on the graph and not a dot, by the way. So if we know this, we can just sketch the graph, and that's it. Determining the range from this is pretty simple. The range is basically the y values or the output, as said before. So here it would be y is bigger than or equal to minus 4. And this is because the lowest y can go is minus 4, since it's the minimum point. Therefore, it can be equal to that. Or, as you can see from the graph, it can be higher than that. So y can pretty much go infinitely beyond minus 4. And that's why you write the range as y is bigger than or equal to minus 4. Next, we're going to look at the discriminant. This is something that tells us the nature of the roots of a function. You can have 2 real distinct roots, 1 real and repeated root, or no real roots. So the formula for this is b squared minus 4ac, and it comes from the quadratic formula, as you can see under the square root brackets. So if b squared minus 4ac is bigger than 0, then that means you have 2 real roots, and this makes sense because in the quadratic formula, when you square root something bigger than 0, then you will get 2 real numbers, a positive and negative one. If it is equal to 0, then you get 1 real repeated root, or also known as equal roots, because if you square root 0, then that means you get 0. And if b squared minus 4c is less than 0, then that means you have no real roots, because you can't square root something that's less than 0 and get a real number. Here we have an example of 2x squared minus 5x plus 8. The first thing you would do is write the formula for the discriminant, b squared minus 4ac, and then all you have to do is plug in the corresponding values of a, b, and c from the equation. And if you don't know already, a, b, and c are coefficients. So a is the coefficient of x squared, b is the coefficient of x, and c is the last one, basically. And so from plugging this in, all you have to do is simplify it. So we would get 25 minus 64, which equals minus 39. So since the discriminant is less than 0, there are no real roots. Next, we're going to look at how to find roots, which you should have come across before. You can either factorize or use the quadratic formula. We're going to look at a quick example. So for factorizing, you just factorize it normally to get minus 6 and 7 here. And if you use the quadratic formula, you can remember what A, B, and C mean in a formula, in a equation, and then plug it straight in the formula. Next, we're going to look at quadratic inequalities, and these are fairly straightforward because all you would have to do is solve for x as normal, and then be careful of the greater than or less than signs, and you can sketch a graph to help you with that. So as an example, x squared minus 4x plus 3 is bigger than 0. And first you just solve it as normal, so you would factorize it and find that x is 1 and x is 3, and then you can sketch a graph to see how it would look like. And since the equation tells you that it is bigger than 0, you would shave the region above 0, and now you know that x is bigger than 3 and x is less than 1. Finally, you'll have to know how a given line is related to a curve. So you would have to know whether the line is intersecting the curve, such as here, whether it is a tangent to a curve, which would look something like this, or whether it doesn't intersect at all. To find out whether it intersects a curve, you have to make the equations equal each other, and then you should find that you will get two values of x. So here's an example. If fx equals x plus 1, which is the line, and g of x equals x squared minus 1, which is the curve, then if you make them equal each other, x plus 1 equals x squared minus 1. And you would just get a quadratic and find two values of x, being x equals 0 and x equals 1. So that means they intersect because, as you can see from this diagram, there are 2 points that intersect. The next thing is the tangent. So you would have to do the same thing as before, where you make the equations equal each other, and instead of finding two values of x, you would find one value of x. And this is because at a tangent, it would look something like that. Something like this, where there's one shared value of x, and they also have the same gradient. So to make sure it's the tangent, you would plug the x value found to the derivative of the curve to find the gradient, and make sure it is equal to the gradient of the line. So here's an example of that. If f of x equals minus 2x squared, which is the curve, and g of x equals 4x plus 2, which is the line, we first make them equal each other. So minus 2x squared equals 4x plus 2. And then from here on, it is just a normal quadratic. And if you plug this into the quadratic formula or factorize it, you would find that x equals minus 1. So this fulfills the first criteria, as you only find one value of x. So to make sure that it is really the tangent, you would first find the derivative of the curve. So then dy over dx is minus 4x. So that's just normal differentiation. And then this is the gradient. So you would plug in the x value found earlier to find the gradient at that point where they intersect. And then you would get 4. So the gradient is 4. And from here on, you can see that this gradient of the curve is the same as the gradient of the line. Therefore, the line, or you can write, therefore, g of x is a tangent to f of x at x